Hi everyone! Today I'm going to be giving simple instructions on how to build a model in Excel for the Hardy Weinberg Equilibrium Lab for AP Biology. This is just going to be a very simple introduction to Excel and to how to build this model. If you want a more in-depth instruction, I put a link in the description that goes to another video. It's going to be a lot longer than this one, but it goes a lot more in depth. But if you just want a simple overview that shows you how to build the lab, then this is the right place. So the purpose of this lab is to create a population that simulates evolution. Evolution is an ongoing process, and we really want to show that by comparing allele frequencies in generation 1 to allele frequencies in generation 5 or 6. And we should be able to see that this frequency is going to change a lot. And that's going to show us that evolution is occurring. To get started off, we're just going to use a simple 1 gene, 2 allele kind of process. This isn't going to get fancy. We're just going to use Mendelian genes. We're going to start off by clicking this arrow in the corner. That's going to select everything in Excel, and we're just going to make it centered. This just makes it easier to read. You don't have to do this, but I think it looks nicer. So to really kick off the lab, the first thing we're going to do is set allele frequencies. So we need to start off with how many alleles we want, the frequency of alleles we want in our generation. And if you know anything about Hardy-Weinberg, the equation, or if you know anything about the allele frequency equation, P plus Q equals 1, you know that our variables are P, which is our dominant allele frequency, and Q, which is our recessive allele frequency. So just for this model, I'm going to set P, our dominant allele frequency, is 0.5. Our Q is obviously going to be 0.5 as well, because we know that P plus Q equals 1. But when we use Excel, we want to connect everything with equations. So just to make things easy, we're just going to push equal sign in the cell or up here in the function bar. Equal sign, equal sign 1 minus this cell. And that's going to give us our Q frequency. So if we ever wanted to come back and change our frequency, let's say we wanted to make this 0.9, then it would just automatically update. Okay. So another function we're going to be using is the random function and is the if-then statement function. And I'm going to show you both of those as we start to build this model. So here we go. So we need a set of alleles to start off a population. And to do that, we are going to make an equation. It's an if-then statement. So we're just saying that if Excel finds something or calculates something, then we want this particular thing to happen. To do that, we're going to push equal sign. That's how we always start. Equal sign if, then parentheses, if a random number is generated. And to do that, we type rand, R-A-N-D, and then an open and close parentheses. So if a random number is generated, and this random number is less than or equals to this number right here, you can either type B1 or you can click the cell. If it's less than or equal to B1, then we want you to write an A, and make sure you put the A in parentheses. Not parentheses, make sure you put the A in quotation marks because we want it to say exactly A. And if this number is not less than or equal to B1, if it is greater than or equal to, then we want it to say B. Don't forget quotations, close the parentheses, and there we have our allele. We can create lots of these. We don't have to type this equation over and over. We can just click this little dot at the bottom. You're going to have a little black cross and drag it all the way down. I'm just going to take it down to there. Oh, I made a mistake. So you can see that all of them are BB, and that's because it's taking from this cell. It's a little confusing. Don't worry about the details. We're actually just going to write this equation over again. So we have this equation here. Make sure you put a $sign right in between this B and this 1. And that's going to make sure that your data copies normally. So we have an A right now. If we drag it down, now we should have approximately 50% A's and 50% B's. Don't forget that $sign in the equation. Okay, we're basically going to do that again. You don't have to type this again, you can copy and paste it, just push Control Copy, push Enter so the equation stays, and then push Control Paste and drag it down. So we generated, each one of these is going to be an individual, each row is going to be an individual. And this entire, this entire column space here is our population. But these are just alleles right now. I'm going to label this by merging and centering this. These are our alleles. We want to make organisms. We're going to make zygotes. And to do that, we want to add up, if this is an organism, our zygote is going to be this and this together. And there's a function for that. It's called concatenate. We're going to concatenate. So concatenate and then push a parentheses. This cell, and then I can't click this one because it went over, but it's D4. So D4. And there, it just added what was in those cells together into the next one. You can click and drag that down. And there you have it. This right here is our population. It has maybe 20, 21 individuals in it. And they have this, this frequency of alleles, this 0.5 frequency. So we have this population, and now we want to see the genotype frequency that we have in this population. So to do this, we're going to add up all of our AA alleles, our heterozygous or our homozygous dominant alleles, our BB, which is our homozygous recessive alleles, and then AB or BA, which is heterozygous. And then count AB. So this is what we're going to be adding up. So to add up, if there is AA in this allele, we're going to do another if-then statement. So to do that, we're going to type =, if, parentheses, if this cell right here equals AA. If it says AA, we want it to put a 1, and if not, we want it to put a 0. This cell says BB, so there's a 0 there, which is good. We're just going to drag this down. You can see that some of these say AA, so there's a 1 there, and some of them don't, and there's a 0. So that's exactly what we want. And we're going to do the same thing for BB. So if this cell equals BB, put a 1, and if not, put a 0. Again, this cell says BA, so there's a 0. That's good. Drag it down. This cell says BB, and that's a 1. So far our model is working. And now we need to add up our heterozygous individuals, and that is a little tricky because BA and AB both count as heterozygous. So we got to make kind of a complicated if-then statement. Bear with me. We're going to push if this cell equals AB, we wanted to say a 1. But if put another parentheses, if this cell equals BA, we want it to equal a 1 as well. And if not, put a 0. And then put another parentheses. Okay, so you see this says 0 because this is AA. Drag it down. So this says BA and there's a 1. This says AB and there's a 1. So our equation worked. Just a side note, you probably noticed that as you're working, things are recalculating as you're going. That just does that every time you push enter. It just redoes it. But because you connected everything with equations, it's all fluid, so it should be fine. If you wanted to purposefully recalculate something, if you push the F9 button on your computer, it should work. I actually have a tablet, so it doesn't work on mine, but try it at home on your computer if you have a tablet too. If you just come up here to your function bar and push enter, then everything will recalculate there as well, so you don't have to worry. So now we have our counts. We want our total alleles, or we want our total counts. We want our total genotypes so that we can get our total alleles. So to do this, this is a pretty simple function. We're just going to type in equal sign sum, because it's just going to add up all the ones in this column, the sum of this number, and then click the corner of this, drag it down, end with a parentheses. So of these individuals, of all of these, there are 5 AA individuals. So we're just going to do this for all of them. It's a pretty simple process. Equal sign, sum, parentheses, select the cell, and then drag it down, end with a parentheses, and there you go. So we have 11 AA individuals, 6 AB individuals, and 5 BB individuals. So now we want the total number of a specific allele that we have in our population. So to do this, total A and total B. So this is just our, we're just adding up all of the A alleles. So we have our homozygous dominant genotype, and in this genotype there are 2 A's. We have our heterozygous, and in this one there is 1 A. So we're going to push equal sign and this number, and we're going to multiply that by 2 because there are 2 alleles. And then we're going to add this number because there is 1 A allele. That should give us our A frequency, or our total A. And we're going to do the same. This number times 2 plus this number. Okay, so right now we just happen to have the same number of A and B alleles. If we recalculate this, it'll probably change. Yep, so now we have 17A and 27B. So now, with this information, we can find our new P and Q for this generation. So to find the new P and Q, we are just going to add up our total, our A alleles over the total number of alleles we have in the population. Again, we can do this in Excel. Let's push equal sign again. Click on this cell, it's K7, divided by, we're going to put parentheses so that our equation doesn't get confused. This, our total A plus our total B. So this is, again, our A alleles over the total number of alleles. And we're going to do that the same over here. This divided by parentheses, this plus this. Okay, we just so happened to come up with 0.5 and 5 again. Sometimes that happens, it evens out. If we recalculate. Okay, now we have a P allele of 0.522 and a Q allele of 0.477. So we can see that this is slightly different than our P and Q from the beginning of this generation. So this is looking at one generation. We want to see multiple generations. So we're just going to copy and paste this. I'm going to paste it right here. You can see that this kept our original alleles. We actually wanted to keep our alleles from the new allele frequencies we have. So we're just going to delete this, and we're going to push equal sign, and then the cell that our new P is in, push enter. And then this came out to be 0.5 again. Hang on, I'm going to recalculate. There we go. So, and then the Q is automatically just going to go in because Excel can be kind of smart sometimes. So this is our P and Q allele. And then this is our P and Q as it goes into our new generation. So copy and paste this generation now because it has that new change in it. And you can copy that over. And it should keep, well, it should keep the new P and Q change. So mess around with that a little bit. I just wanted to show you how to make a graph really quick. You can do that by selecting this data, pushing insert, and then making a bar graph. And that kind of shows you your allele. You can do that at the beginning and the end. You can also take all your data and put it, this is from a chart I made before, take all your data and put it in a line graph that shows the change in allele frequency over the generations. Just make sure you type in the specific cell you want. And that's it for building this model. Thank you.